Well, Season 3, Episode 8, Part 2. All right, so Part 2 requires us to find the equation of the tangent to the function. This when x equals 4. Now, you may recall that the tangent line is a line, it's a linear equation, y equals mx plus c. So, we want to find y equals mx plus c. We need m, we need c. To find m of course is the gradient. So the first question is, what is the gradient of this line when x equals 4? To do that, well, we're going to have to find dy dx. We're doing this properly. Dy dx from that formula. There are a couple of ways we could go about this. One of them is to use the chain rule, but you know what, I don't really feel like using the chain rule. I'm going to chicken out. I'm actually going to expand that x take 5 squared because it'll be a lot easier to differentiate once I've done that. So I'm going to rewrite that. So x take 5 squared means x take 5, take away x take 5. When you expand all that out, use the claw. You can also use the rule if you happen to remember the rule. So negative 0.5, we're going to get x squared. You're going to end up with take away 10x plus 25 when you clean all that up. Plus 3, I can then expand all this out. I'll have negative 0.5 x squared plus 5x take 12.5 plus 3. I can then combine those two elements, negative 12.5 plus 3 plus 5x, take, what's that going to be? Take 9.5. That is a lot easier to differentiate than what we had before. So if I do dy dx now, 2 comes out the front, 2 times a half, it's going to be 1. I'll be left with just negative x there, plus 5. And of course we lose the constant when we differentiate. So the question was, well, what's the gradient when x equals 4? All we need to do now is put 4 in this little formula and we're going to find the gradient at that point. So dy dx equals negative 4 plus 5. M is 1. So the gradient in our formula here is going to be 1. Now from previously we need to find c. Thankfully the first part of this activity made us find the exact point. We already know that when x equals 4, y equals 2.5. So we can use what we've got to find the value of c. So in y equals mx plus c, we know that at this particular point, 2.5, y is 2.5, m is 1, the x-coordinate was 4, plus c. From that, so 2.5 equals 4 plus c. To get rid of the plus 4 here, I take away 4 from both sides. C will be equal to negative 1.5. From that, remember what we have to always look back to our question, make sure we answer our question. It wanted the equation of the tangent of the function. We now have m, we now have c. We can say the equation of tangent line at x equals 4 is y equals 1x, which is just x, take 1.5. Woohoo!